HIW is one of the premium finishing schools that aims in enhancing the academic learning of engineering candidates through industry-specific training that helps you build a career in core engineering sector. Okay. Today we have Ramchandra Niruri sir, who is the founder and technical director of EV Retron Energies, a startup company which focuses on creating the clean energy technologies. He has dedicated his life to developing new energy sources that are both clean and efficient for the planet. Sir's success comes from his passionate belief that clean energy can play an important role in creating a sustainable future for all the people. His dedication continues to lead him towards impacting positive change through innovation and technology-driven solutions. Okay, and we also have Deepesh Kumar Barla, who is the co-founder and managing director of EV Retron Energies India Private Limited. He has completed his graduation from BVRIT Hyderabad as an electrical and electronics engineer. He has 4+ years of experience in electric vehicle industry. He has also trained more than 6,200 industrialists and students in the field of electric vehicles. Deepesh is someone who is very passionate about electrifying the Indian future and providing clean resources and contributing towards a green India. So from here, Ramchandra sir will take the lead and continue, guys.
Yeah, good morning, Kavya.
Good morning, sir.
Yeah, very good morning, all the participants, those who are joined for your time during the Sunday. Yeah, we welcome you all, the collaborative webinar of HIW and Retron Energies. Hope my voice is clear. Yes?
Yes, sir, your voice is clear.
Yeah, thank you. Just a minute, I will share my presentation. Yeah, just a minute. Slideshow. Okay. Yeah. Yeah, once again, we welcome you all and thanks for the opportunity. I would like to thank HIW and all the participants. Yeah, this is just a brief presentation for 10 minutes. So then we will go for a virtual tour of Retron Energies and Emulator. Yes. Yeah, hope my voice is clear and the presentation is visible to everyone. Yeah. Can anyone confirm, please?
The audio is clear, sir.
Yeah, thank you. Yeah, once again, good morning all. Today webinar related to this EV emulator, that is electric vehicle emulator. The very purpose of this product development, because to enhance the knowledge and to train the students as well as faculty related to EV technology for better understanding of battery characteristics and controller and motor characteristics. Because there are huge job opportunities coming up in this particular domain, particularly in India. So just I'll go through the presentation. Yeah, coming to electric vehicle technologies, opportunities and challenges. So if you look at today's scenario, so many companies investing in EV sector, particularly in India. So since last 1 to 2 years, uh, we have seen many companies like Ola Electric and other many companies, they started their business. And the battery sector also going very big way in India. So big people like Reliance, Tata, other companies also entering into this business. Yeah. So this is very important for us. The future runs on electricity. So everybody should agree this. As automotive sector completely transforming into EV industry. So as IC engines and petrol diesel engines are going to convert to complete electric by 2030. So as on date, many vehicles, two-wheelers, three-wheelers, four-wheelers are coming in the market. So this is going to create more than 50 million jobs. So EV industry may create 50 million indirect jobs and 10 million direct jobs by 2030. So that is the reason our students and faculty, our community should be ready to grab the opportunity. So we have very good future in this sector. So if you look at the EV sales penetration by 2030, so this three-wheeler segment is increasing rapidly. We can expect by 2030, more than 80% three-wheelers going to be electric. Similarly, passenger cars and buses as well as two-wheelers. So if you look at the electric vehicle sales in India since 2013 to 2022 last year, there is a huge growth. So if you look at 2021 and yeah, so if you look at the 2021 and 2022, it's a 200% growth in EV sales. So we are expecting next to couple of years, 1 to 2 years, this is going to be 400% growth. So that is the reason we have interacted with many professors and industries like HIW training centers. So in this sector, EV sector, many job opportunities coming up, but students are lacking about the skills. So for better understanding of the EV segment and EV components like battery, motor, controller, so what are the characteristics, how to understand basic things. And if you look at this particular slide also, it is EV sales trends in India. So this is the last year report card. So it's a huge growth in 2022. This is taken by eVahan website from Government of India. So if you look at the specific job opportunities, consultancy in EV sector. So every day, most of the job portals, they are placing the jobs related to EV segment. If you look at the job description, so like system engineers, technical support engineers on electric vehicles, automotive electrical engineers, and BMS algorithm engineers, battery related R&D, battery testing and validation engineer, and storage segment, and energy management, technical expert, production manager, associate engineer, power electronics related. So in this power electronic related, huge job opportunities. Every day I'm seeing many career opportunities in the LinkedIn and other job portals. And lead team battery modules, assistant engineers, like these are the uh, few job opportunities we have listed for the better understanding of the students as well as faculty. And many more job opportunities coming every day from the job portals, and many companies like big software companies also investing into this. Okay, so this is the main reason we come up with this product called EV emulator, electric vehicle emulator. And we are trying to train all the students, faculty, those who are interested in learning and grab the opportunity in EV industry. Apart from that, anybody interested to do research in this domain also. So this is the excellent product what we have developed. So it is completely indigenous product and completely smart DMS also developed in collaboration with our partner. It's a completely customized product. So this is the smart lab learning
completely customized product.
prepares students for tomorrow's world. So the CB emulator is a comprehensive piece of project-based learning technology that offers learners a wide range of opportunities in the field of electric mobility. Okay? It is rooted in research and is designed to prepare all the learners for life beyond the classroom. So if you look at this particular slide, you can see the electric vehicle emulator. It's look like this. So it's a complete pack, including the bench and including the display, including the battery pack. So everything we are going to deliver. Now we are going to understand this battery pack by Mr. Deepesh Kumar. So he will explain how it works, what are the important components, what are the experiments we can do, what kind of research we can do on this. This is a battery pack. This is also developed like fully functional see-through battery pack. Every student and everybody can easily understand. So how it is connected, series parallel combination, how what are the different components in the battery pack. So like that, and this is a smart control board. This is also developed in-house to understand in a better way. So what are the different ports are there, how it should be connected. And this is the dashboard. You can get each and every parameter of the battery pack as well as motor data like current, voltage, DOD, SOC, etc. to understand. And if somebody doing research on battery management system, you can also do some algorithms, etc. Yeah, this is our brief journey. So at present, our trusted partners are Sri Vishnu Educational Society, BVRIT, and we are also tied up with SRM University and Presidency University and Arbutus Consultants, Agni Solar and HIW. You can see some pics here in this presentation. So we tie up with HIW, and this is a great opportunity given by Institution of Engineers India. So recently, last month, there is a national program conducted at Institution of Engineers India. We have displayed this product. Many senior people from DRDO and other academic community, like principals, they are visited. So they suggested this kind of products much needed at present for the academic purpose. And we are also tied up with the SRM University, Andhra Pradesh. We had an MOU with that. Yeah. If you can see this particular pic, is the chief scientist from Central Electric. Yes, somebody is. Who is Surya? Yeah, please mute yourself. Thank you. Yeah, if you look at this particular pic here, so he's the chief scientist from SECRI, is a Central Electrochemical Institution, which is located in Chennai. So they are completely working on the advanced cell chemistry, battery packs. He's also visited our startup last month. And if you look at this particular picture here, the last corner picture, so we have displayed this product during recent program happened at JNTU. So this is Edu Summit 2023. So many principals and academic senior managements, they came and they appreciated this particular product. Okay. Yeah. Just this is a brief history of about the EV retron energies. We have started this particular lab and work last 2 years back in a small room. Just it is a 200 SFT. So we worked on various projects. We worked on e-cycles, battery packs, and other conversions, e-conversions. Then we worked with the DRDO project and we worked with IOCL also. Then we developed this EV simulator for academic purpose. We are also doing so many other works for the EV industry. Yeah, thank you for giving this opportunity. We look forward to see your interest on this, and I request Mr. Deepesh can take lead and explain about this EV simulator. Yeah. Thank you. Yeah, Kavya.
Yes, sir.
Yeah.
Deepesh is visible for everyone now. Can you please stop it here, sir?
Yeah. So good morning, guys. I'm Deepesh Kumar, currently the co-founder of EV Recton Energies. So welcome again and happy New Year. So I'm a startup co-founder basically into battery technology. So we have been doing a lot of work in EV domain. So today with no much worries, so we'd like to introduce our EV emulator. So this is electric vehicle emulator device, which is purposely built for testing of EV battery packs and BMS system. Okay, so we have been learning a lot about EV technology, and we have already trained more than 6,000 students and faculties and industrialists in EV technology. Okay, we have that kind of expertise in both solar and EV. So why this device? So whenever we were trying to move towards institutions and all, so people are asking us, they wanted practical oriented training. So we did not know what practical oriented was. So we have developed some testing machines in house to test our BMS and also our battery pack and also our whole system. So this is how the invention is born. So we then developed a machine which is very easier to learn for students. So EV emulator is a project-based learning technology where people can do experiments and learn it. Okay. So what is it now? So it is a project-based learning technology. So I'll go through some components. So this is everything that is there in the test rig. Okay. You can see there is a transparent visible battery pack here, and you can see there are which is an industry grade battery pack. Okay. You can just switch it on and switch it off. You can see there are so many cells connected in series and parallel. So this gives you this gives you a wide understanding about how batteries are made and what is the technology that we have been using in putting the cells together, where are the wires coming from, and how do we thermally improve it, and what are the thermal constraints involved. So we'll go to the battery pack again. So let us also go through the BMS. So if you can see the chip over here, this is a battery management system. So this is the battery management system and also the IoT system, the master and the slave configuration. Okay, so if you're unaware of the battery technology, so battery does need a management system. So batteries, there are so many cells over here, like there are 24 cells right now, and there can be more than 200 cells to 300 cells in two-wheeler and more than 3,000 cells in four-wheeler as well. So how are we going to manage all the cells here? So the battery management system does the work here. So you can see there are the switching circuit, then also the power distribution unit, and also the IoT board here. Okay, and there are also multiple sensors connected, which will be placed inside of the battery pack, which will give you the values over here. And we also have developed an interactive dashboard. If you can see on the screen over here, we can see what is the voltage and the state of the BMS and also the current right now. So there are so many other faults that you can see here. If there are any fault in the system, okay, basically we are having like many types of battery packs and BMSs. So this is a smart BMS system developed by us in collaboration with the other company. So where we are able to figure out each and everything that is there in the system. Okay, so there are multiple various faults here. We can also look at the state of charge, state of health, maximum temperatures and all. Okay, I'll come to the screen again. Now let us see a different setup here. That is a smart controller board. Okay, yeah. So this is a smart controller board where everything is integrated here. So the battery, the BMS, and also the motor, everything is integrated here. This is much like the brain of the system. Okay, while the heart of the system is the battery pack, so the brain of the system is a controller. So in the controller, we have developed in such a way that it is easier for us to assemble. It is easier for us to assemble and understand what are the various things happening there. Okay, you can see there are hall sensors, there are batteries, a display connector, and all these things, right? And So this is the whole setup. I just walk you through how this is being run. Okay, so how do we switch it on? So we just switch on the battery pack, and then the BMS is activated. So once the BMS is activated, we have to turn the switch on here in the controller unit, and then we have a knob over here. Just switch it on, and the system is turned on. So now you can see there is the speed and the RPM over here, which is much like an electric vehicle. The whole electric vehicle is on the test strip here. Okay, and there is also a motor here. We also have a breakdown of the motor. We can increase or decrease the loads and also figure out the change in system. So as I keep the power here, you can see the motor is rotating. Okay, and you can see there is some kind of discharge happening there. And if I keep on increasing the load, you can see in the change of current, right? Okay. As to keep on increase the load, that there is a change in current. Okay, so with this, we are able to figure out the battery characteristics, the motor characteristics, and also the BMS characteristics. If we go down and I'll just click on view over here, you can see there are individual cell voltages. Okay, so you can see you see guys? There are individual cell voltages here. 3.2, 3.27, 3.29. There are 12 in series. So every individual series is being monitored. Okay. So if there is any imbalancing fault, the fault will be shown over here. Okay. So we'll also look at some other components, other values here. This is CBAL. This is cell balancing fault. This is low battery fault. This is high battery voltage fault. This is open wire fault, and there are so many other faults in system. So it will be easier for us to look at what is happening inside of the battery pack and what are the thermal constraints and each and everything. Okay, and you can also generate graph over here. So whenever you increase or decrease the voltage and the current, so there will be a graph generated, and also that can also be downloaded. Okay, so what else can we do over here? Okay. So what else can we do? So as a student, we can perform multiple experiments here, much like figuring out the motor characteristics, figuring out the battery characteristics, and figuring out the BMS characteristics as well. Okay, you can also download all the information from here. Yep, I guess you're able to see it now. So every aspect of the whole system is being viewed over here. Okay, and what are the experiments that we can do here? The battery study, detailed battery study, where you can figure out the optimum voltage, the lower voltage, the higher voltage, the cutoff, the over temperature faults, and everything can be studied over here. So this is much like an industry-grade battery pack, and which is equivalent to the battery pack that we use in the scooters or electric vehicles. Okay. So with this amount of knowledge, we can actually apply for many jobs and also get skilled and also get hired by many EV companies. Okay, so this system is solely giving you enough knowledge on each and every component of the system. Okay, now we'll just talk about the battery pack right now. You can see there are multiple cells over here. I'll just also see. So each and every cell can be viewed over here, and we have a separate barcode for it, just like what people in industry do. So every cell is being tested. So we can individually test each and every cell and also monitor its voltage, monitor its current and temperature conditions as well. And you can see there are multiple wires coming out of it. So that is actually going to the BMS. Okay. So this is the main terminal of the battery pack. So the positive and the negative terminal, and also the JST ports. So what we call as the JST ports. And here we also have the battery voltage and also the power switch. Okay. And you can see there are multiple connections in between. These are the nickel strips, so which are connected to the BMS wires again. Okay. And here then it goes to the BMS system. So BMS, the power distribution unit, then also control algorithm unit, and also there is IoT board here, which actually transfers information to the system. Okay, and the control system. There's a lot more to talk about BMS. So we can do various experiments on the BMS. So we can see where the voltage is being cut off, and also if it is balancing the cells or not. So what do you mean by cell balancing? Can also be researched over here. Okay, so many industrialists and researchers are also opting for this product so that they can do thesis or else do project on this. So if we as industrialists, we use this particular emulator so that we can, yeah, so that we can figure out, what is the performance of the BMS and if the BMS is functioning well or not, and all these things can be look over here. Okay, so this is a smart controller board. So everything is here. You can see there are multiple phase wires connected. So these are the phase wires of the motor. So motor is connected here, and this is the power unit, the battery input, the brakes, the throttles, the hall sensors, and everything is connected over here. Okay. Yeah. Okay. Very curious, guys. You want to learn, understand anything in detail right now? Any questions? So I'd like to be more specific about it. If you want to be more specific about the component. So here are also the thermistors, the NTCs. So this will be connected inside of the whole system. Okay. So yes, this is the whole power electronic circuit. So these are the temperature sensors. As per AI standards, so we need to have at least 4 temperature sensors. Okay. So these temperature sensors will be put inside of the battery pack or else put inside of the motor controller, wherever there is heat generating aspect. Okay. So we have seen a lot of battery pack failures, right? So battery pack failures can be detected by this system. So if there is any temperature changes, the battery pack's temperature can be detected, and also we can isolate the whole system. Okay. So there is, all other systems here which can communicate with the whole main board. So any other queries, guys?
Yeah. Did you hear about it? No. But it's not.
Yeah.
I just unmute myself. Yes. You want to see the question?
Okay, I've got a question here. Okay. So the question is about small brief on how BMS, IoT, and management board works. Okay, components and etc. I mean, any DC-DC converter and DC-AC converters. So the whole BMS dashboard can be seen here, right? Hello, yeah. I guess you can hear me. The whole BMS system is here. So battery management system gets the data from the whole battery pack. Okay. So battery management system is connected to the battery pack, so which is inside of the system. And that system is actually monitoring each and every individual voltages. Okay. There is some different algorithm here, whichever, whenever there is any fault, or else whenever there is any regular operation is being done, everything can be noted here. Okay. If a manufacturer is having like 100 batteries, so each and every battery can be monitored in a particular single dashboard. Like if there is any fault, and if there is any, you can also tag, see the location of the system. So where is the battery and how much kilometers has it traveled today or tomorrow, and how much battery is being consumed, and is there any fault in the system previously. So the good thing about BMS, the smart BMS, is that before there is any fault in the system, like before, like a customer is driving the vehicle and he is going to experience the fault. So before the fault is being present, so we can also predict the fault and also take necessary measures. Like if your battery is going to be degraded tomorrow, or else there is a lot of imbalancing fault and all. So we can directly contact the customer and also tell him that your battery has to be serviced immediately. Okay, so each and every aspect of cell can be monitored over here. So regarding the incidents of the electric vehicle explosions and all, so battery management system plays a main role here. Okay, so there are multiple cells in the system which has to be monitored every second, right? So if there is any fault in the BMS system, if it is not able to detect any temperature raises, or else any imbalances in the system, or else any open wires in the fault, or else any mechanical impacts in the system, then the BMS will not be able to isolate the whole system, right? So BMS already manages all these things and makes sure that the EV is safe. Okay. Is it true that normal piston engines always have a higher speed capability as compared to EVs? So EVs actually use motors which are very much higher, having higher torque and higher this one. Okay, so there are multiple motors that are used in EVs, see SRM motors, VLDC motors, and all. So these motors can have a lot of torque. Like if you can see the torque of a normal electric cycle is 36, and if you can go for the bike, it is more than that. And now we are also using gearbox along with motor. Okay, there are systems, electric vehicles, which are having highest torque than IC engines. IC engines are very robust and also very bulkier. But whereas you see now in the latest technology, we can see a 50 kilowatt motor in the size of a smaller scooty engine. So that is how powerful the electric motor is. So battery is connected in series or parallel. So battery is the combination of both series and parallel. So whenever you have a system, you actually manufacture it accordingly. Okay. So in here you can see both the cells are connected in series and these cells are connected in parallel. So this is a 12S2P configuration module. So which is suitable for electric two-wheeler section. Okay. If you're going for electric three-wheeler, there will be 300 such battery sources. So when we are building a electric vehicle, we need to look at the motor ratings, what is the requirement of the load, what is the requirement of the vehicle, speed, vehicle range, everything will be figured out, and also calculations has to be done. So with that calculation, we fix out the battery calculation. So how much range should be, if it is a 100-kilometer, customer needs 100-kilometer range, then we have to design the battery pack as per that standards. Okay, and I will also like to know different standards that are in the market right now, and every particular standard can be studied over here. Like AS 156 and 038 and 048 are applicable right now in the market, and that standards have a lot of hard points, like there should be pressure bands, and also every cell should be monitored, and also data should be logged of each and every cell. So this kind of whole systems can be viewed in this particular emulator, and a student or else an industrialist or else any other guy can actually have lot of experiments can be done over here. Okay. So how does the system manage power distribution, for example, during idling, starting, and cruising? Yes. So depending upon the load and road conditions, so there are so many conditions for it. So depending upon the load conditions and the road conditions, and also the speed and all. So the battery will manage the power which is consumed by the motor. Okay, there are different algorithms are there. This type of vehicle motor is voltage same for all? No, all the voltages do not have the same voltage. For smaller systems, it starts
Which type of motors are used?
yes. Yeah, there are many types of motors depending on the application. So if you're using for smaller application, then BLDC motor can be used. And if you're going for longer application, BLD motor actually uses permanent magnet there. So as the size of the BLD motor increases, there can be some magnetic issues, permanent magnet issues. So for higher motors and all, we use AC motors, synchronous reluctance motors, switch reluctance motors and all.
Shall we go back?
I'll give you a demonstration again.
Which
AC voltage. You can see the individual cell voltage over here. So the battery current can be noted over here. You can also view and also download the data. So this is the whole battery current. You also download the data and store the data for future references. This is how the battery packs data will be used. Okay. You go here and you also see what is the maximum. You can also see the maximum temperature over here. Temperature is now like 25 to 27 degrees only. 27 degrees maximum temperature. So go up to more than load can be increased or decreased, and also you will see the change in current here. While increasing and decreasing the load. We'll go see a look at the voltage.
Hello.
Yeah.
Hello. Okay.
So this graph can be clearly seen here. The increase and decrease of the voltage current. Now we can, so what can you do with this data right now? So you can see how the battery pack is behaving. These are the motor consumptions, right? So motor is getting a high current and the peak current. So whenever there is any peak, so we'll note that peak down and figure out the whole best configuration for the system. And also if there is any peak current beyond 12 to 13 amps, then the BMS is going to cut the system down. Okay. So now the peak current is somewhere around 9 amps. Okay. And if it goes beyond 12 amps, then the system is going to cut because the whole motor is configured for this system only. So any questions, guys?
Because there are n number of questions coming down. You can take a question from Narsimha Kumar. How does the system manage power distribution, for example, during idling, starting, and cruising?
Okay. So I can see the questions. I'll start from the last one. Full electric BEVs today have an average range of, yeah. So what type of battery is used in electric vehicle? So nowadays we are having like several battery chemistries, out of which NMC and LFP are the word widely used. And we also have lithium titanate. We also have sodium ions coming out, which are having higher density battery packs. So there are several chemistries in lithium and family itself, which are having high density and high power capabilities. So, but yeah. And nowadays we are also looking for chemistries which are much more safer, because we have been seeing incidents and all. So the batteries which have cobalt in it are very much explosive, and so we are looking for any other additional systems like that. And there are companies now who are trying to make out hybrid batteries. Hybrid batteries, in a sense, they are using multiple chemistries to make a single pack which can actually provide high power and high energy capabilities. How much time will it take after discharge of full batteries? So it depends upon the load and speed. So this battery pack is capable of giving at least 3.5 hours of continuous power.
Manage power distribution.
So since this is a single system where there are not multiple sources here, if you're having like multiple sources, example supercapacitor and battery pack. So see, if you're having a multiple source systems, much like a supercapacitor and a battery pack system, lithium and battery pack, where we need high power and high energy capabilities, so we'll be using a switching system where during starting different source of the power will start. Like if we need more power during the starting, right? So supercapacitor will do the work, and after starting idling and all, so maybe the lithium and battery can do the work. So we have also developed a project for IOCL, basically which figure out which source to engage. Can the same arrangement used for four-wheeler? If not, what modifications should be done? Yeah, the same arrangement can be used for four-wheeler. I believe that you're talking about the EV emulator, right? So emulator, each and every component is there in the system. Like whatever you figure out in the whole motor, the electric vehicle, every component is in the system. This is much like what you see in electric vehicle. There are somewhat few more components that are there. There is a power mostly consumed in EV. So Motor is the one who is going to consume a lot, because that is obviously the answer, right? If you are talking about the losses here, the losses will be more in the BMSs if you are using a passive system, where the batteries has to be balanced by passive technology, where the individual cell voltages, energy, excess energy should be released as heat energy. Okay, if you are using a passive one. What if you are using active balancing, then no energy is being consumed. Anything else? Okay.
Yeah. Once again, hello everyone. Yeah, I congratulate Mr. Deepesh as well as entire team for developing this. You can see just show whole system, right? Just show whole system. So this is a complete EV emulator along with this bench and the system and complete setup. The complete setup is indigenous and developed here. So this complete setup is going to deliver if anybody interested. And if you look at this particular system, so you can easily get the knowledge on complete EV technology, not only battery, not only BMS. So you will get all knowledge. So how the BMS works and what are the different types of protections are there and how the battery chemistries are there. This is one of the chemistry LFP and there are many more chemistries are there. If anybody want, we will also provide that chemistries. But this system provides complete EV technology and EV knowledge to students as well as faculty. So that is the reason we have developed this. And this is the customized software. So nowhere you will get. And this you can also do research on this and you will get complete knowledge and your students get trained and many job opportunities will be there. Okay, here you can conduct many experiments like example, electric vehicle assembly. And you can see this is complete plug and play type. You can see all the connections. It's a complete plug and play type. After supplying, we will be providing 1-day training on this. So completely plug and play, we will give manual and we will be training. And you can study the, yes, you can study electrical motor characteristics under different loads and study on battery pack characteristics and detailed inspection on battery management characteristics and detailed study on electrical charger characteristics, then hybrid vehicle assembling and testing. So all this can be done and your students as well as faculty get trained. So I request all of you, please remember, so EV and PV is the future. So electric vehicle technology going to create lots of jobs. So I request all the faculty members, those who are joined, so please concentrate on EV, even PV technology also. This having huge job opportunities. Yeah, now I request just, I want to introduce the team developed here, Mr. Sandeep Kumar. So this is a complete old team. This is the product development they involved, Neha and Sandeep and other team members. Okay.
Okay, carry on.
Yeah, Mr. Deepesh, you can also join here. Madan sir. So Madan Mohan sir, he is having vast experience in the training domain. So he is our academic partner. So we are concentrating and much more development. Not only this product, we are going to develop. This is one of the products. We are working on complete EV technology. So complete EV technology lab, which is going to set up in future in universities as well as colleges. And we are also working on PV laboratory equipment also, PV lab setup also. This is going to create awareness and training for the students for future jobs. Yeah, thank you, Madan sir. Yeah.
Guys, we'll take up the questions now, one by one. So you can drop your questions in the chat box, guys. We will go one by one and answer them. I see a lot of questions coming in the chat box while the class was running, while the webinar was running. So let Just get a moment and let's take a moment and go back to those questions and discuss each and everything. I request everyone to put their questions in the chat box rather than unmuting themselves and speaking up. So Deepesh, you're ready? Let's go with the questions.
Yes, I'm ready.
Yes. So we'll go from the last, from the first.
Yep.
Yes.
What are the safety parameters are taken in battery department? So safety starts from the cell. So since there are like 40 plus 50 components in a battery pack, every component of the system should be tested, like the cells. So what we do is that for individual cells, we have a separate barcode for unique barcode for it, where each and every battery is being charged and discharged, and also their data is collected, so that for future we have to, if there are any systems that have to be changed, then we can actually do that. Okay, so every system cell voltages and have to be monitored and then grouped accordingly, right? So cell sorting antam dani. So basically what we do is that we club the cells which are having best parameters. Like if the batteries are not equal, or else their voltage, current, temperature, conditions, if these things are not equal, then we cannot group them together. Safety precautions. Electric vehicle. Yeah. So when
Deepesh, you're on mute. Deepesh, you're on mute. Can you please unmute yourself?
yes, I guess
Yes.
you're able to hear me.
Yes. Now we can hear you.
Okay, what do you want me to do? Go from the first question?
Yeah, we'll go from the last question, Deepesh. There's a question from Srinivas Rao. How much power consumption in EV vehicles?
So that depends upon, again, on the motor load, right? The bigger the motor is, and depends upon a lot other parameters, the speed that you're traveling, the road that you're traveling, what is the load on the vehicle, and also the gradient and all. So that is something related to vehicle dynamics. We cannot actually speak out. Yeah.
Okay. There's another question
Okay.
from Pooja. How much voltage of battery can be used in EV two-wheelers?
So two-wheelers currently they are using 48 volt system. Ather is using 48 volt system, but so many others are using 60 volt system. 48, 60, 96 as well.
Okay. There's a question from Yashwant saying that what are the safety parameters taken in battery development department to be aware of the battery burning issues?
Yes, so battery explosion issues can be related to a lot of aspects. Maybe there can be a small wire damage, or else there can be a charger issue, or there can be some mishandling of the battery issues. Right from the manufacturer end till the customer end, there can be plenty of reasons why a battery is failing. But in order to prevent all these conditions, in order to make sure that the battery stays safe and also the person riding the vehicle stays safe, we use some smart management system. So this battery management system actually predicts if there are any faults that are going to occur in the future, and it will take action. So I'll repeat that word: fault isolation. Fault detection and isolation are the things that happen in the BMS. The fault is detected through multiple sensors in the system: the thermal sensors, the voltage, the current, the AH, and many other sensors. It detects the fault and also isolates the whole system. So in between the controller and the battery pack, there is BMS, right? So BMS makes sure that battery is not giving power whenever there is any issue reported.
Okay, there's another question from Mr. Peter saying that is it true that normal piston engines always have high speed capability as compared to EVs?
No. I don't think so, because IC engines actually use gearboxes. Like in electric motor, we don't even need that, right? So electric motors are capable of delivering high torque in the starting itself, but whereas IC engine cannot do that.
So there's another question from Ram saying that which type of motors are used in electric vehicles?
Yeah, different sets of motors depending on the application. So motor selection criteria is there, like the motor torque, required torque, what is the required RPM, and what is the size of the system. Okay, so if you're going for, we can also go for BLDC, SRM, then PMSM, then AC motors, ACIM, induction motors, and all.
Okay. There's a question from Om. Is there any rectifier used? If yes, which kind of rectifier?
Use a lot of it, but if you go start talking about it, it will be a very deep concept. So we will take it personal.
Okay, the next question is what are the disadvantages of EV?
Sorry.
What are the disadvantages of EV?
Okay, EV disadvantages. That's again, if you are in the future, there might be scarcity of power, and if you are still trying to run the power out of thermal power plants and all, so we are going to face issues. So major drawbacks of issues, there are very less, but when compared to IC and all, there are more higher advantages.
Okay, there's another question, Paul. Why are you choosing EV vehicles? Why not introducing hydrogen gas vehicles?
Not hear you, Kavya. Okay. So EV sources hydrogen. Yes, even though hydrogen is very simple and we feel that hydrogen can be sourced from anywhere, but for hydrogen, for developing hydrogen, we need electricity in one of the process. So that is again consuming electricity. And in order to store hydrogen, we need much, bunks like petrol bunks, okay, that are very huge, and that needs a very compressed chamber, right? So hydrogen power plant will be somewhere, somewhere another place, and that has to be transported again to a hydrogen fueling plant. Okay, and maybe it will take some time for India to develop this hydrogen gas vehicles, but EVs right now can be charged, have the advantage of charging at your home itself. You can charge your EV through a normal socket, whereas you cannot charge your hydrogen vehicle at home, right? You have to go to the fueling station, and fueling stations development is very crucial because it has to be compressed at a very high pressure, and yeah, there are so many things that can happen. But in the future, India is actually looking for a change in this one.
There's a question from Srinivas Rao saying that can you provide any practical training for 1 week for our students as a part of project point of view? Yes, we provide that training, right?
Yes, we can do that.
Yeah, you can contact us. The contact will be shared in the chat box. Okay. Then there's another question called electric battery system vehicles are suitable to Indian type continents. Recently, a lot of bikes burned due to battery issues.
Yes, we are actually building vehicles that can be used in India, right? There are so many startup companies are coming out, and they are making vehicles that are suitable to Indian road conditions only. So in order to gain knowledge on that, so you have to make sure that you study, each and every component working principle and all, right? So this EV emulator actually helps you in getting to that sector.
Okay. There's a question from Chandar saying that name some hybrid electric vehicle models.
So Toyota Camry is there. Toyota Camry is there, and currently only Toyota vehicles are out in the market.
Is there any possibility to build battery backup banks for EV vehicles?
Yes, it is possible, and people are doing it right now.
There's another question from Chinna. In India, 80% of electricity is generated in thermal power plants. In future, coal power plants. In future, there won't be any coal. How that situation is faced in addressed in EV by EV?
Okay. Only 57% of electricity is being generated through thermal power, and 17% is generated through solar. And people in government are actually have targeted nearly 820 gigawatt of consumption in the upcoming years, right? So we're going to increase solar power. Startup companies are figuring out how to generate power. So there's so many solar, so many other.
One second, Dipesh.
Yeah.
Can you just repeat yourself? The last few sentences. Dipesh, you're on mute. Can you hear me, Dipesh?
Yes, I can.
Yes, yes. Yeah, you were saying something. Okay, let's take the next question over here. Has Deepesh sir said that the batteries are connected in series? Let us say if any one of the batteries drained rapidly and the rest of the batteries have charged, does this kind of problem affect the BMS?
It does not affect the BMS basically. So BMS will be stopping the whole system. Okay, even if one of the series in the battery pack is drained out totally, so the BMS main functionality is to prevent that failure, right? So it will stop the whole battery from functioning. So if there are any imbalances such, it will try to balance it while charging or else while discharging at a very lower rate. And if it is discharged at a very higher rate, it will make sure that it isolates the system.
Okay, there's another question from Sampath saying, what are the reasons for EV blasts?
Yes, as I already said, there are plenty of reasons, right from the manufacturer end till the customer end. If the manufacturer is not manufacturing it as per guidelines and is using improper manufacturing practices as grouping of different cells, using of cheap quality material, and that can also be from the customer end. If he's not using the right charger for it, if he is trying to replace the chargers or else mishandling the battery packs, so this can be issues. Plenty of issues. We cannot really predict which one is the main reason.
Okay, let's take the last question over here. The other questions will be answered through one-on-one basis by mail. Okay, the question from Vasan: can we measure the current value during starting of motor, because starting current will vary in millisecond? How much is the accuracy in terms of millisecond?
Okay, yes. If you can see the dashboard, already we have shown it, right? In the starting also, if your system is very well connected to the IoT board, so we have two different backup systems. So every of your data will be stored in a particular data logger, which is equipped inside your electric vehicle itself. So each and every 0.5 second data is being stored. Okay, so that is how accurate the system is. Even if there is any milliampere change in the system, we can also see that. Right from nearly 200 milliamps to 500 to 1 amp, also accuracy is there.
Okay. So guys, thank you so much for your time. The other questions will be answered through the feedback link. Please fill the feedback link that is shared in the chat box, and you can post your questions over there in that particular link. Okay. As we have a new batch for electrical students, we have a course for course electrical system design that is starting on Jan 23rd. You can register. If you're interested, you can register and give your interest in the feedback link only. We'll get back to you. We are so glad that we could see so much crowd over here. Okay. Yeah. So, any other questions? Please give it in the feedback form. Thank you for your time, guys. Please check the chat box for the feedback link, guys. You will receive your e-certificate in your registered mail ID in a week's time. Okay. Please check your spam before saying that there's no certificate given to you or something like that. Okay. And thank you for your time. Hope you this was a very knowledgeable session. We as HIRB are signing off. Thank you.